section 10.6, we're learning about areas using trigonometry. So the first thing you need to recall is that the area of a regular polygon is 1/2 times A times P, where A is the apothem and P is the perimeter of the regular polygon. And here's an example, and this example is from your notes. You have a barn. It's going to be in the shape of a regular octagon with a 56-foot diameter. And we're going to find the area of the barn floor. So you can see I have an octagon here that would resemble the barn floor. And this octagon can be split up into these isosceles triangles. And you see that one isosceles triangle that I have here. Now, so let's think about what we know about this. And it's easier to go ahead and look at this from this triangle. So I'm going to take the triangle out. And we're going to get rid of the octagon, or just make it smaller for now. And so if I take this one triangle out, then I need to go ahead and sketch my apothem here. So I'm going to construct the height of that triangle. And so this is my A, or my apothem. And I know it has a 56-foot diameter. So your diameter is going to be, if we look back at our octagon, our diameter is going to be through the center here, and so this would be here. So if you think about one of those triangles, then one of the triangles is going to be half of that diameter. So that means that when we come back over to our triangle, that this is going to have a side length of 28, half of 56. Now we can use that to help us find this. So thinking back on our octagon, to find the angle measures in this octagon, we know that it's n minus 2. It's got 8 sides. We subtract 2, multiply by 180. When we do that, we're going to get 6 times the 180, and that's going to give us 1,080. And then, so that means that the total interior angles in this octagon is 1,080. So then we take that 1,080 and divide it by the 8 angles that exist in this octagon. And when we do that, we find out that each angle in the octagon, we know that they're all congruent because it's regular, is 135 degrees. So that is this angle that's 135 degrees. Okay, but in our triangle, if you think about our triangle, which would be here, it's only going to be half of that. So when we're looking at this triangle here, this angle is not 135 degrees, it's half of the 135, giving us 67.5. And now that we have all that labeled, we're really ready to go and start finding the area. So let's just put this away. Okay, so for the area of this regular polygon, we know the formula for area is 1/2 times the apothem times the perimeter. Now right now we don't know the apothem and we don't know the perimeter, so we're going to have to do a little work to find each one of those. Let's go ahead and find the apothem. So we've got a 67.5 degree angle. We're looking for the apothem and we have the hypotenuse. So then we go and we figure out what trig ratio we would use for that. So that's opposite and that's hypotenuse. So to find the apothem, we're going to say sine of my 67.5 degree angle is equal to my apothem over my hypotenuse, which is 28, and that's at 8, which means my apothem is going to be 28 times the sine of 67.5, which is going to give me about 25.9. Okay, so once I have that, I can go up and start using my equation. Let's see, let's scoot this over. Just put this over here and work back in my equation. 1/2 times my apothem, which is 25.9, and now I've got to find my perimeter. I'm still looking for the perimeter of this figure. So to find the perimeter, then we're going to be using this part, okay, and there are 8 of those around the octagon. But for this triangle that we have, we're going to need to use half of that. So what we're going to say is that this distance is y. And then to find that y, once we find that y, then we can find the perimeter of our octagon. So we're looking for the adjacent side this time. We have a 67.5 degree angle. Y is our adjacent side. We've got our 28, which is our hypotenuse. So that means that we can say that the cosine of that 67.5 degree angle is going to be our adjacent over our hypotenuse, which is 28, which means that y is going to be 28 times the cosine, that 67.5 degree angle. We find out that y would be about, and this is approximately 10.7. You could actually leave that in your calculator, the 28 times cosine 67.5, to then go and find a more accurate version of your perimeter. But for right now, we're going to use the 10.7. So once we have that's 10.7, that's 10.7. This is the 10.7. For each triangle, we have two of those. So we're going to take this and multiply it by 2 to get the entire piece of this triangle. Now, how many triangles are in the octagon? Well, there are 8 sides of that around, so that would be times 8. So this part, the first part, is going to give you the base of the triangle, and then the times 8 means there are 8 bases around that. So this would actually equal our perimeter. So that's going to give me that the perimeter is approximately 171.4. So once we have that perimeter, we can put that into our equation. And then we have everything we need to go ahead and calculate the area. So this would tell me that the area is 2,219.6, and the dimensions here were given in feet, so that's square feet. And that's the area. Okay. Let's try another problem. In this example, we're finding the area of a parallelogram. We are given that it has a 24 degree angle. One side length is 13 and one side length is 27. We're not given dimensions here, so we would just say units. So I'm going to go ahead and construct a perpendicular so that we know the height. We know that the area of a parallelogram is going to be base times height. Now, right now, we know that the base is 27. We do not know our height, and that's what we're going to find. So if we have a 124 degree angle, we know the angle opposite of that is also 24 degrees. And using that, then we can find the height of this figure. Because we have one angle, and we know the opposite side, which is our height, is what we're looking for, and then we do have, since that's perpendicular, we do have a hypotenuse. So given that information, then we can say that the sine of 24 is equal to our hypotenuse over 13, meaning that our height is going to be 13 times the sine of 24. And that would give us a height of about 5.3 units. So we have, fill that in with 5.3. And then that gives us about 143.1 square units. And that's the area of our parallelogram. Okay, now example 3, we're finding the area of a regular decagon with a side length of 10 centimeters. Okay, so we have all of these sides are 10 centimeters. And they're all congruent because it does say it is regular. And again, like we did with the octagon, we can pull one triangle out of this, making it a little easier to deal with. So let's use this. So we know that this is 10. We know that the area of a regular polygon is 1/2 times A times P. Right now, we could use the 10 to go ahead and figure out what the perimeter is. So we have 1/2 times A, which we don't know, but we know our perimeter would be 100. Each side is 10. 10 times 10 would give us the 100. Now we're going to use this triangle to help us find the apothem. So that would be our apothem. Now once again, we're going to have to find out what this angle measure is, and we're going to do it just like we did last time. This time we have 10 sides minus 2, and it's going to multiply that by 180. And that's going to give us the interior angles for this decagon. And once we do that, then we're going to go and take that, divide it by 10, and then divide that by 2 to figure out that this angle here is 72 degrees. And once we figure out that angle is 72 degrees, then we know that this length is 5. We're looking for the apothem, so we have the adjacent, and we're looking for the opposite, which means we're going to use the tangent of our 72-degree angle is going to be our adjacent over our hypotenuse of 5. So our, that was supposed to be our opposite or our apothem. So our apothem is 5 times tangent of 72 degrees, giving me an apothem of 15.4. And I can now take that and plug it in up here. And that's going to give me that the area of this figure is 700 and about 770 square centimeters. That's the final answer.